Welcome to the Data Hall YouTube channel. In this video, we are going to talk about the t-tests in R. So what we are going to do is this is what we call mean comparisons. So we test whether the mean is significant or not. So that means significantly different from one value, or the mean between two different groups is same or it is different. For that, we are going to use the auto data. So let's first load the data. We have the data over here. We have different cars, their prices, their mileage, their weight and length, etc. And then there is one variable of interest, that is whether the car is domestically produced or the car is a foreign produced product. So we have different types of t-tests. One is called a one sample t-test. Then we have two sample, or what we also call independent sample t-test. Then we have the dependent sample or the paired sample t-test. So let's start with the one sample t-test. So we have this variable called the price of the car. So what we want to do is we want to take that variable and we want to see whether its mean value is different from 6,000 or not. So our hypothesis is that the mean value of the mean price of the car is 6,000 in our data set. So we are going to use the t-test function and take the data, the column, the specific column, specify the specific mean that we want to test, and press Control Enter. And what we are interested in is the p-value. So this p-value is greater than 0.05. That means we accept the null hypothesis. And in this case, the null hypothesis is that the mean value is equal to 0. The mean value is equal to 6,000. So because we are not able to reject the null hypothesis, so we conclude that the mean value is equal to 6,000. The alternate hypothesis has been specified over here, which says that the true mean value is not equal to 6,000. So what our conclusion is that the mean value in this data set is equal to, the mean price is equal to 6,000. If we were to check whether it is different from 0 or not, the mean value is different from 0 or not, so we would specify the mu as 0. And what this says is that the p-value is quite low, it is less than 0.05, so we reject the null hypothesis in favor of alternate hypothesis, and the alternate hypothesis says is that the mean value is not equal to 0. So that was one sample t-test. We apply it when we have a data and we want to check its mean value. Okay, let's move to two sample t-test. It's also called independent sample t-test for a reason, because we consider that these samples are independent of one another. So we have this variable called foreign, and it contains whether the car is domestically produced or a foreign produced car. So we want to compare the mean price between these two categories of this foreign variable. That is, we want to see whether the average price of a car is same whether the car is produced domestically or it is produced in a foreign country. So what we do is we use the t-test and we take the price variable, use the tilde sign, and then specify the categorical variable, and obviously specify the data. If I press Control Enter, I can see that our p-value is greater than 0.05. In this case, the null hypothesis is that the mean value of the average price of foreign and domestically produced car is same, and in this case we are going to accept that null hypothesis. The alternate is that the mean value, the true difference in mean between the group domestic and group foreign is not equal to 0. So that is, their means are different. So the null is the means are same, and the alternate is that the means are different. Now in this case, we had our data stacked over one another. So our categories were stacked over one another. But some cases we would have, let's say, a variable called foreign price, and then we would have a column called domestic price. In that case, what we do is let's generate that data using the split function. I'm going to generate that data. So now we have this groups list where we contain, it can be data frame or a list. The idea is that now we have two columns. One is domestic car, and then the foreign car. We have 52 observations in domestic cars and 22 observations in foreign cars, and we want to compare their mean. So the result would be exactly the same, but the way we specify is different. We just specify these two columns now. And R would compare, now R would generate the exact same p-value, the exact same mean values, right? It would also generate the mean values. So previously the domestic car's mean was 60.72, and currently it is also 66,072. So so there are different ways of doing this two sample t-test, and this is what we have demonstrated. The next is paired sample t-test, what we also call the dependent sample t-test. And for that, I'm going to use a different data set. I'm going to use the chicken weights. And what we have over here is that we have the weights of the chicks, and at what day that weight was taken. So that is, the 0 means on the date of the birth, and 2 means 2 days after the birth. So what we are going to do is let's create some category, filter the data, just have the two categories, that is weight on day 0 and weight on day 2, and we want to compare whether their mean weight is different or not. But in this case, it is different from our previous data. In previous data, we had two different categories and they were totally independent. But in this case, the subject is the same, that is the same chicks, and we want to compare their weights. So what we do is we use the paired sample t-test, apply the function, specify the column, the weights column, and then the categorical variable, and specify whether we want to do paired sample t-test or not. If we do not specify this parameter, then it would apply the one sample t-test, right? This is the two sample independent sample t-test. So this argument is important for it to do the paired sample t-test. So let me apply this, and again we are going to look into the p-value. It is less than 0.05. In this case, the null hypothesis is that the two means are same, and the alternate is that two means are different. So our conclusion is that based on the p-value, that the two means are different, because when the p-value would be less than 0.05, we would reject the null hypothesis and accept the alternate hypothesis. So I hope this was useful. Do subscribe to this channel and do hit the bell icon.